shows I, well, so in this example here, it shows that I is declared here and then declared again down here, which works just fine. We can actually copy and paste this, and we'll see that it works just fine. Let's go here. Let's go to the top. And of course, it does it all on one line. Okay, so we can see this is just fine right here. Int I is declared twice, but it's declared within the scope of the for loop, which means whoever declares it owns it, and it can be used that way. So, it's almost like you're saying that I is its name, but it's really identified not only by its name, but by who owns it. Or maybe you might say the family name or the surname or something like that. So that I is owned by 4. 4 cannot own 2 I's. But each 4 can own 1, or can have 1. So that works. The other example will not work. This example will not work. And actually what we can do is just to show you how that works is that if I declare int I here, you've got a problem now. And it says I is already defined in method. And that's because although 4 has its own scope, it also belongs to the scope of method 1. So 4 cannot redeclare something that method 1 is already declared. So it's got to use a different name. So that's actually not allowed. So it gets a little tricky with the variable scope. But the best thing to do is probably to avoid this is to try and use different names. Especially when you're a beginner. These scope rules can get really confusing. So, the best thing would be to just create different variables. Maybe int f1 for loop 1. F2 for loop 2 or something like that. That would probably be the best way to go. So, you don't really have to worry too much about the scope rules if you're using meaningful variable names that you don't really duplicate. It's not, and that's probably, as a beginner, a good rule to follow so you don't get that confused. Correct method, this shows you the correct one, which you just saw. This will work fine with no errors. So if we undo all this stuff and I get rid of that, I'm fine. So that method will work. It's got some issues as far as doing everything on one line, but other than that, that's readability issues. Okay, so that'll work just fine, and this should be on a separate line as well. The incorrect one, again, will not work. Why is this incorrect? He's not declared anywhere. Oh, it's redeclaring X down here. That won't work. Because the 4 is owned by incorrect. And that's kind of why we have the indentation too, is so that it's really obvious what belongs to what. So because these are indented under 4, it's visually obvious that these belong to 4. Although Java itself doesn't care. This is more for human beings to see the indentation. Java cares about the curly brackets. That's what Java uses to determine what belongs to what. But that's because Java doesn't have eyes. It's just looking at actual characters. We've got eyes and we visualize things, so we indent to make it visually obvious to us that what belongs to what. And since X has already been created out here by the parent of 4, then 4 can't recreate it. That's not allowed. Method header is essentially the signature plus a couple of extra things. So we talked about and we said, okay, this is the signature, right? Well, if you want to know what's the header is just a further expansion. It's basically everything on the entire line. That's the header, including the return value. You can write a method once and reuse it anywhere. You can do something called information hiding, and it reduces complexity. Basically, it's a divide and conquer strategy. You have something and you divide it into smaller, easier chunks. So do one little thing, then one little thing, and one little thing, instead of having to do it all at once, learning it all at once, or trying to get it to work all at once. It's almost like an assembly line process that works so well for automobile industry. The math class, and I know we talked about this the other day, the math class offers some constants, and I know we talked about this in the comparison, saying that the arithmetic you would do plus, addition, subtraction, division, multiplication, basic arithmetic, and algebra, or arithmetic I should say, is done longhand. You write it out. But for the more complicated stuff, most people can't remember the formula for sine, or cosine, or tangent. I do not remember those formulas at all. If you know, it good for you. But most people do not remember those formulas. So that's why we have a scientific portion to a calculator. In Java, the math class is like that scientific portion of your calculator. It holds a bunch of methods in it that does a lot of the same stuff that you would see in a scientific calculator. Again, if we were to just use math, and in NetBeans it's real easy. You type math in uppercase M, hit the dot, and it shows you everything you got. So you're going to see everything that is on your scientific calculator and then some, because it's got even more stuff. So it's quite nice for when you have to do stuff outside of basic algebra. So it's got a bunch of different methods. You can look through all the different examples. Anything you can do on a scientific calculator, you can do in the math class. Exponential methods as well. It's all there. Nice little class. Ceiling and the floor and all that. Rounding a double to an int, it looks like. Oh, x is rounded to the nearest integer. So you've got some nice capabilities there if you're having an issue with some sort of math issue, not quite getting the formula, or you're not sure how to do something and you know it's math related. Always a good idea to hit the math class first to see if the solution is there. Pretty good chance it probably will be. Min, max, absolute values. You can see that max has overloads for math, has overloads for max. The random we'll see is used. It's used in game programming all the time. The random method. I think we saw that a little bit already. How to generate numbers. This will generate a number between 0 and 9, because it will essentially take a millisecond, multiply it by 10, and that will wind up being somewhere something of 0 to 9, because it'll be from 0.1, it'll actually be from 0 to 0.9. And this here will give you 50 to 99. The reason that works is this will generate 0 to 49, and then you add 50 to it. So you've got general ways of doing it. Generating random characters. So you can generate random characters too. Really easy to do. Got that one. Generate random character. So we'll look at the method that does it. So how does this work? If you remember, on the second class when we went over how characters were stored internally as a numeric value, it goes all the way down to binary zeros and ones, and then up to numerics, digitals, like the uppercase letter A is number 65, and that a character is really just a limited special purpose integer, meaning the character actually stores the digital number or code for that letter. So if you pass in the letter A here, you're actually passing in the number 65. If you pass in the letter B, you're actually passing in 66. And the letters are in numeric order. So B follows A, C follows B, and so forth. So because it's really just an integer, you can use the math.random to generate random characters. It's basically going to generate a random integer in some range, and if you cast it to a character, which is what we're doing here, then it simply converts it to that numeric value to the character equivalent. And you can pass in a couple of characters, like that. And you can pass in, you can say lower letters only, uppercase letters, digits, or any random character. Okay, so you see right here in this class it doesn't have a main method. And earlier we talked about if you make methods public and static, they're basically publicly available to everyone. So if I go back over to my solution, I can say something like, go down to main, let's get rid of all that right now, and say, and I hit the click, and look at this, I get all these random stuff. So typing random integer dot and say get random character, and I'll just say char, or I could even just say system.out.println is essentially exactly the equivalent of saying system.out.println math.pi. Why is it? Random is a class we create, and we made the methods in there public and static. That does two things. Public makes it available to anyone, which is what math did with pi. Static means that you don't have to instantiate the class first to use it. And let's put that off until we get to the lab 3 example at the very end, because then we'll talk about instantiating variables. So if I go ahead and I do this and I run it, it generated a random character, which looks like, if you look at it, it's like an Asian character of some kind. And of course, I could say, I think upper character is what's that? And we could say random character, uppercase character, right? So we can do that. And this will now give us, if we run it again, letter M. If we run it again, you get something different. It's always going to generate a random number. We don't know what it's going to be. So, and works the same way as using math. That's basically all math is. A method with a bunch of public static utility methods. Okay?